Welcome to Gartner ThinkCast. I'm Alexis Waringa. This week, we're exploring one of the most persistent and evolving challenges with AI, hallucinations. If you've ever used any kind of AI tool like ChatGPT, Claude, or Copilot, you've undoubtedly come across a few too many errors that are stated as fact. But why does this continue to happen? Gartner Chief of Research Chris Howard will walk through a few uncanny examples, the techniques employed by neural networks to constrain and refine these answers, and even how hallucinations can actually be helpful in thinking outside the box. Now, here's Chris.
So when generative AI really hit the public consciousness in the beginning of 2023, the end of 22, beginning of 23, people were fascinated by it, right? We talked about how people were camped out in the uncanny valley, kind of experiencing this interaction with this thing that seemed to be human. And some of the funny bits about it were that it would make stuff up, right? So if it's a prediction machine, essentially. So if it hit a spot where it really knew something should happen but didn't have data to fill it, it would make something up. So, for example, at Gartner, a number of analysts asked generative AI tools like ChatGPT to generate a biography for them. And it was very interesting what happened. So, any public information around these analysts that existed that had become part of the model would come out. So, some of their background, their history, and it got most of it right with a few mistakes. But in almost every case, ChatGPT created an obituary for the analyst. So, why? Why did that happen? Well, what we think is that the most of the biographies it was trained on, so GPT was trained on, were historical biographies or maybe Wikipedia biographies, where most of them actually were from, people who had passed. So it thought in its mind, in its predictive mind, that there should be an obituary that's part of this biography. So it would create one. It would sort of make one up and say, unfortunately, Chris Howard died in 1993 of blah, 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 blah. Funny, right? Not funny if what you're trying to do is to make a decision that informs a business strategy or, makes a decision for a loan or something like that. So naturally, there was a lot of concern about generative AI and its hallucinations. Now, it has changed quite a bit since then. Because if you think about where hallucinations come from, it is a predictive machine filling in a space where it believes that something should go, and it's drawing from its experience, from its training to do that. So part of reducing the hallucinations is to actually reduce the training space and to constrain it, either by saying only use this data and maybe ignore this other type of data. So you're narrowing in on a set of data that it's going to draw from and it's going to draw its intelligence from. Or you could do things like using filters on the input and the output of the prompt to make sure that the citations it's using are real, and it's going back and interrogating the output of the prompt itself. Eventually, what's happening, of course, is multi-agent systems bring that to another level, where you have agents within a complex system that are actually working together to solve maybe a hard problem. For example, maybe it's a diagnosis problem in healthcare, and you had multiple agents interpreting, say, the records from a patient to try to determine a diagnostic path. Now, in a real hospital setting, this is done by panels of experts. Some of you know that I'm a cancer survivor, so I survived stage 4 lymphoma about 8 years ago. And what I learned, because I was interested while I was going through it, like what am I experiencing? That there was a tumor board at Yale New Haven Hospital that met regularly to discuss complex cases, and they would all come from slightly different positions. Some from a diagnostic position or a clinical position, some from testing. But there are others that represented, say, the financial side of like how much are these tests going to cost and so on and so on. And they would debate with one another to figure out what the best course of treatment would be. Now, imagine if you had a system where agents were debating with one another, coming from very specific perspectives of knowledge, or grounded in a refined type of knowledge, and using perhaps reasoning as a means of interacting with one another to come out with a suggested output. Now, in the case of diagnosis, that might be order more tests or ask more questions, or maybe we know enough now to actually give a probabilistic determination of an outcome. The power of these types of systems, most of which are sort of in a state of research right now and being tested, but this offers another way of counteracting this hallucination issue. Multiple agents with knowledge, reasoning from those bases of knowledge, and then working together as a collective to figure out what's the best response to this problem. There's one other emerging type of technique used for neural network that I find just fascinating, right? And it's sort of shaken all the webs off of my Calc 1 and 2 from university, in that there are lots of physical probabilities that can be predicted using differential equations. So if there's motion, there's something stochastic or random that's happening. You sort of put all of these things together, you can describe many types of events using these types of equations. Now, this makes sense for perhaps the mechanical world or the physical world where you actually have objects that are moving. But it also, you can use equations to determine like options pricing or mean time to failure of a piece of equipment, or any of these other sort of complex variable systems where there's movement and irrationality perhaps associated with them. Now, what we're seeing is the emergence of something called a PIN, PINN, which is a physics informed neural network. And essentially, what it does is when the network is being trained, it's being trained using differential equations. And so it's constraining the output from these models to answers and probabilities that conform to the equations. So anything that falls out of the possible answer to these equations is excluded, and things that fall into the realm of this sort of possibility are included. So you end up getting a much more accurate set within a tolerance. Okay, so that's a pretty sophisticated approach. But the thing that all of these have in common is you're constraining the decision space, either by constraining the data that it uses, perhaps shaping it with equations like I've just talked about, or using logic within the system to refine a response or an answer. All of these things are still probabilistic answers in the neural space. So in using the neurosymbolic, the neuro side of that. And that's the power of these systems, is that they provide optionality or they provide a projected course of movement as opposed to discrete answers that are always 100% correct. If you want 100% correct, there are other systems to use to do that, things like knowledge graphs or rules engines, which are also part of the AI set of capabilities, but they're much more on the deterministic side. So you have probabilistic, which we're trying to narrow the probability space, get you much more specific answers within that set of tolerances that you have to help you make a complex decision. So, in the diagnostic case, there might be 2 or 3 options that come out of a system where you have agents working like that. And then that's handed to human experts to refine their decision making and speed it up potentially. But that's the power of a probabilistic system. And then, of course, we've talked about combining the two in much more complex workflows. So, you're constraining the decision space, but you're using the tools for the power that they bring. Give me options, narrow those options so they're potentially more correct, and then maybe pair it with something else. So these are sophisticated examples. What are the things that you should do, and what is Gartner talking about? None of this happens unless you have invested properly in your data. And that's an easy statement to make, but a difficult one to realize because the data space and architecture is a complex one. So clearly, you need really great, clean data with good governance wrapped around it, what we would call AI ready data. That's so important, right? Because these agents or systems or groundings rely on data that you're providing to actually help them be more accurate. So this is a very, very important point. The other thing is thinking again about the problem space that you're applying this to. So there are some types of problems where optionality is what you seek. I need a few really good options to choose from. There are others where, yeah, I need a really good answer, the right answer, right, as fast as possible. That's a different set of techniques. And like I've always cautioned here as we're talking about AI, AI is not the solution to everything. There are some problems that aren't hard enough for AI to solve. That where you have good predictive analytics, for example, or you have even RPA for automation, where like that's good enough. You don't need the heaviness of AI. You use AI when the problem space is complex enough that it's beyond humans' ability to process in a useful business useful period of time. So the other point I'd make here is that hallucinations can sometimes be useful, in that maybe a hallucination shows you a different angle to a problem that you've never thought about, or the thing that it uses to fill a vacuum or fill a space actually is a good answer, but you hadn't thought of it. Like it maybe actually will give you a shift in your design perspective. And so embrace hallucination as possibly a different way of seeing the world as opposed to simply being something that is wrong. So we've moved a long way from machines hallucinating obituaries for people that are still alive to much more sophisticated ways of constraining a decision space. And I think that's, for me, what's happening in AI right now that is absolutely fascinating. And I would love your input on this because it's a hard problem and we need to solve it all together. At Gartner, you'll see some evidence of this through our IT Symposium series coming up in the fall, and clearly through our data summits and series where we're talking about the AI data ready piece of this, AI ready data. The other pieces, of course, in the software engineering space, which was being impacted by how do you integrate pieces of logic together and so on, all the way down through the infrastructure. So what you'll see across Gartner is sort of attacking this interesting, complex problem space from all angles of what we do, and then applying it to domains like finance or marketing or supply chain or risk management or engineering. So name your discipline, all of this kind of flows out together. What a fascinating time to do what we do. And I'm not hallucinating that.
Thanks for listening to this latest episode of ThinkCast. That was Gartner Chief of Research Chris Howard. To learn more about this topic, follow the links in the notes. ThinkCast will be back wherever you listen to podcasts a week from today. In the meantime, please rate, review, subscribe, and share with a colleague so neither of you will miss it.